Hello, I am Yahya
And I'm Arda-Yahya.
Today we will talk about our Digital Electronics Laboratory term project. In this project, we are responsible for designing a fake Quidditch game implemented on FPGA boards coded via Verilog HDL. This project is designed to be within design specifications as realistic and accurate as possible within the reach of our knowledge and capability. And the game consists of two teams, red and blue, 3 goals for each team, and a ball and a bludger. The game is simply to reach 9 scores through opposing teams' goals or have the highest score when the time of 3 minutes and Verilog code is constructed in such a way that we can actively play the game with 60 frames per second through a monitor, which is driven by VGA of the FPGA.
Okay, so of course, while doing this project, we have some design specifications. So first of all, the game should be easily playable. So the goals should be fairly large to make the scoring easier and to have fun, of course. One of the players in each team should move vertically, and the other ones should move horizontally. And the players and balls are circular and they are all rigid, so they cannot pass through each other. They cannot cross each other. And there is also a ball called bludger, and which basically scatters randomly from the field boundaries, and when it hits a player, it disables that player for 10 seconds, and but bludger keeps continuing to scatter randomly around the map. So the other specification is that each game should last 3 minutes, and there should be a scoreboard to indicate the current scores of the teams and the left time. And the orientation of the field should be vertical. So while designing our game, we used hierarchy in our Verilog codes and design. So our code consists of a top module that is named as show, and in which all the connections of other modules to other modules are constructed. So we have two most important lower submodules. They are called VGA and CPU, and we have other, well, we can say less important modules, like they are called clock 60 generator and clock 1 generator, which basically generates the clocks, and BCD timer module, and namely the VGA module consists of two submodules that are called as pixel and sync. And actually the pixel submodule consists of the pixels that we will print on the map on the screen. So they consist of like the holes, the goals actually, the radiuses of players, and the midline, the scoreboard, all the info that will go on the scoreboard, but it doesn't decide the info on the scoreboard, it just prints them. So the VGA module takes clock 50 as an input. Clock 50 is a 50 megahertz clock signal, and it takes it as a input and generates a 25 megahertz clock signal inside it. So, and do all the work with that 25 megahertz clock signal. The second module in the VGA is the sync module, and this module is needed to acquire anything on the screen. And what this module does is that it meets the timing constraints of the screen, so we can see a picture or a video on the screen. So for 640 to 480 pixels resolution, the VGA modules should have 25 MHz of horizontal synchronization and 60 Hz of vertical synchronization. Hence, all the timings of the data transactions are adjusted and satisfied in this sync module. So we take a 50 megahertz internal FPGA clock and divide it to obtain 25 megahertz and 6 layers to satisfy the conditions. Hence, all the timing constraints of data transactions are adjusted and satisfied in the sync module. So, about the CPU module, Yahya will talk about it.
The second important module of our game is the CPU module, and we named that module as CPU because, as in computers, all the decisions in our games made in this module. For example, a player's movement, start, restart, stop, pause buttons, balls movement, player ball collisions, and so on. And the hardest problem that we confront in this game, in designing this game, was the player ball collisions. Because we want to make an realistic and physical collision. We don't want to divide the directions of the ball into certain angles. We want it realistic as possible. We have implemented an algorithm that uses vector operations. It's basically takes the ball velocities, perpendicular projection, and takes the symmetry of the vector velocity of the ball with respect to the normal line of the players, and the result of the ball player collision was perfect.
Okay. To conclude, creating such a game using Verilog gave us such a great experience because we have there was a lot of problems along the way, but we have come up with practical solutions to all of them, and finally at the end we were able to do everything almost perfectly, let's say, and we created like pretty good physical collision. Like it's quite realistic, and it was so hard for us to do. We spent over like two weeks for that, and we believe that we kind of added some cool features to our game as well, so it looks kind of good. So in the end it was such a great experience for us, and we learned a lot about the hardware description languages, and I can say that it was pretty good, and thank you for listening.
Thank you for listening.